Okay, and these are examples of solving trigonometric equations. We are going to look at the method of factoring, and we're going to do examples 7 and 8, and then later I'll do examples 9 and 10. So many trigonometric equations can be solved algebraically by using factoring. Sometimes we need the quadratic formula, sometimes we have to use basic identities to write equivalent equations that involve only basic equations. So let's take a look at this example here. Number 7 says find the solutions of 3 sine of x squared minus sine of x minus 2 equals 0. And we want to do this just in the interval between negative pi and pi. So we're not looking at all solutions. We're just looking at some specific ones here. So what we want to do is we want to factor this. And so we're going to take 3 sine squared of x minus sine of x minus 2, and we're actually going to factor it. Now you could use substitution here. You could say let u equal the sine of x if you wanted to, and then we could say that we have 3u squared minus u minus 2 equals 0, and then factor it. So if you have to use substitution, go ahead and do that. If you can do it without, then that's fine also. I'm going to go ahead and use this method of substitution to show how it's done here. This can be factored relatively easy, that we have 3u plus 2, and u minus 1 would be our factors. If we take 3u times negative 1, we get negative 3, and 2 times u is 2u, so we'd end up with negative 3 plus 2 is negative 1. So then we have 3u plus 2 equals 0, and u minus 1 equals 0. So then we just solve these equations. So we have 3u equals negative 2/3, or u equals positive 1. And so, oops, this is just u, not 3u, because we subtracted 2 and then divided by 3. So what that means then is that we have the sine of x equals negative 2/3, because we had let u equal sine of x, and we have the sine of x equals positive 1. So they want us to solve this between negative pi and pi. So we are going to look at, let's look at the easiest one first here, sine of x. We know that sine of x equals 1 when x equals pi over 2. Okay. So there's one of our answers. Now for negative 2/3, just a little reminder here, and let's look up here, that we're talking about on the coordinate plane when the sign negative, and that would be in the 3rd quadrant and in the 4th quadrant. So we're talking between 0, negative pi over 2, and negative pi when we find our answers. So what we're going to do is we're going to find our reference answers here. So we're going to find this angle here. And so we're going to do the inverse sine of just positive 2/3. To help us out here. All right, and let's find out what that equals. So, and we'll call that theta. So we'll take our calculator, do the inverse sine. So second sine of 2/3. And we get 0.73, so we'll just use 2 decimal places. So this equals 0.73. All right, so in the 2nd quadrant then, or in the 3rd quadrant here, so we're going to take negative pi and we're going to add 0.73. And then over here in the 4th quadrant, we're just going to subtract 0.73. So our answers are going to be x equals negative 0.73. And then we have pi minus 0.73. Oops, let's try it again. Pi minus 0.73. And so 2.41. So we get x equals negative 0.73, negative 2.41, and pi over 2. So to find this answer, first we have to factor, and so I factored it. If you need to use substitution, like letting u equal sine of x, you can do that. and factor it, and then check to see where these numbers are at. So like the negative 2/3, we know the sign's negative in the third and fourth quadrant, so we had to work there. And reminder that it's between negative pi and pi, so the third and fourth quadrants in this case are going to be between negative pi and pi, because if we start at negative pi over 2, then 0, then this is back to pi over 2, and then back over here to positive pi. So if we're talking about going from negative pi over 2 to pi over 2, we're actually talking about a circle that starts here and goes around and ends back there, just like that. So here's our answers for example 7. Okay, so we're going to take a look at another example here, example 8. And this one says tangent of x cosine squared of x equals tangent of x. And what we want to do in this case is we want to get everything on the same side first of all. You cannot divide by tangent of x. Even though we're solving an equation, you can't eliminate a trigonometric function by dividing because you lose values there. So here we have, we're going to get everything on the same side. So that's the first thing we always want to do with these quadratic or these trigonometric equations, is make sure everything is on the same side of the equal sign, so we can do our factoring. So here then, if we look at both of these two parts, we have tangent times cosine squared minus tangent, and these both have a tangent in them, so we're always looking when we're factoring to get the greatest common factor. In this case, that's tangent. And then I'm left with cosine squared of x minus 1 equals 0. Now one thing to note here is a reminder that cosine squared of x minus 1 is not equal to sine squared. And that would have to be 1 minus cosine squared for that to be true. So now I have factored this, so now I can set both factors equal to 0. And so we have tangent of x equals 0. That's simplified. Cosine squared of x minus 1 equals 0. We can do two things with this one. We can either add 1 to both sides and then take the square root, or we could factor it also. I'm going to go ahead and add 1. So that means we have cosine squared of x equals positive 1. So then we take the square root of both sides. And don't forget, whenever you take the square root, you get a positive and a negative. All right, so we want to take a look at these values. These are on our unit circle. So when this tangent equals 0 and when this cosine of x equal plus or minus 1. So if I think about my unit circle here, and that's pretty nice. So if we think about the unit circle, we've got, let's see, here's our point here would be cosine is 1, sine is 0, and tangent is also 0 here. Okay? And that means that over here at, this is at 0 degrees or 0 radians, over here at pi, then we have negative 1, 0, and tangent 0 also. So tangent is 0 at 0 and pi, and cosine is 1 at 0 and negative 1 at pi. So our answer here then, since it doesn't give us a specific integral like the last one did, we're going to have to include all possible answers. So we'll say that x is equal to pi times n, because every time so at 0 it's a true statement, at pi it's a true statement, then back at 2 pi it's going to be a true statement, and at 3 pi, because every time it hits the horizontal axis it's going to be a true statement. So we'll say x is equal to pi over n, and where n is an integer. Okay, and you have to make sure you say that. Now, sometimes they use k also, but we'll go ahead and we're going to use n instead of k here.